This video is going to cover section 7.2, which is titled Calculus of Parametric Curves. In the last section, we introduced the idea of what parametric equations were, what the graph of parametric equations look like, that curve. And in this section, we're going to look at some applications, and they're going to be applications that involve us being able to find the derivative of parametrically described curves. So let's go ahead and jump into what the derivative is going to look like when we have parametric equations. First question for you, what information do we need to know? What information do we need to know in order to find a tangent line to a curve at a particular point? Go ahead and think about that and answer that question. Okay, well, hopefully you said that we need a point. We need two things, right? We need a point, some point xy. And then the other thing we need is the slope. We need the slope m. Well, let's go ahead and find that for a parametric equation. We need to find the slope. So let's start like this. Suppose we have parametric equations x equals f of t and y equals g of t that represent a curve y equals big F of x. All right, well, if that's the case, then we can take that y equals big F of x and we can substitute in the parametric equations, y equals f of x and y equals g of t, x equals f of x and y equals g of t. So what do we get then if we plug those in? Instead of y, we're going to have g of t. And then on the other side, we're going to have f of x. But instead of f of x, and I just noticed there's a typo here. This should have been a t. I think I said t, but it didn't really look like a t. That's x equals f of t. So instead of x here, this is f of x. Instead of f of x, this is going to be f of little f, of t. Well, we need to know what the derivative is, right? So we need to take the derivative of both sides. And we're going to do that with respect to t. So when we do that, on the left side, that's easy. That just becomes g prime of t. But on the right side, now we have a function inside of a function. So what rule do we need when we have a function inside of a function? Yeah, we need the chain rule. So let's go ahead and do that. We take the derivative of the outside function, f prime, keep the inside function the same, and then the second part of the chain rule, we multiply by the derivative of the inside function. And that, again, this is the chain rule. And now that we've done that, we can go ahead and rearrange, because now we can see that f prime of f of t is equal to g prime of t over f prime of t. And of course, g was y and f was x, so we could also just call this y prime of t over x prime of t. And that's how we find the derivative of a when we have parametrically described curves, and ultimately that's also going to tell us the slope, right? Because the derivative tells us the slope. So that's what we see here in theorem 7.1. whenever we have parametric equations, x equals f of t and y equals y of t, then we can find the derivative, assuming that x prime and y prime exist. We can find the derivative by taking y prime over x prime. Okay. Remember, again, this can be used to find the slope. So example 1, let's apply this now. It says find the tangent lines to the parametric curve given by the parametric equations x equals t to the 5th minus 4t to the 3rd, and then y equals t squared at the point 0, 4. So what are those two things we need again? We need a point. Oh, we already got that. That's good. But we also need the slope. We need to find what the slope is. And we can find that by, again, taking y prime of t over x prime of t, like we just found on the previous page. So y prime, that's pretty easy. That's just 2t. It's the derivative of t squared. And then x prime of t is going to be 5t to the 4th minus 12t squared. Now, make a note about this, because we don't just call that the slope. That's actually, that expression gives you the slope at really any value of t, right? This gives the slope at any point or any value of t. So the next question is okay, that point we have right there, 0, 4, what's t equal to? Because I can't exactly plug 0, 4 into the slope formula. I can only plug t's in, right? So how does that correspond? How does 0, 4 for x and y correspond to t? Well, we only have one set of equations that gives a relationship between x and t and y and t, and that's our parametric equations. So, for example, if we take our x equation, we have x equals t to the 5th minus 4t cubed. Well, we know if we're trying to figure out the point 0, 4, we know that x is 0. So we can say 0 equals t to the 5th minus 4t cubed. How do we solve an equation that looks like this, a polynomial equation? Well, we usually want to factor. So we can factor out a GCF of t cubed, and that's going to leave t squared minus 4. And then that means that t cubed is equal to 0. And it also means that t squared minus 4 equals 0. First one tells us that t is equal to 0, and the next one says t squared is equal to 4, which means t equals plus or minus 2. So we have actually 3 answers there that will make x equal to 0. We have 0, we have positive 2, and negative 2. So we also need to look then at y, because we know that y, which is equal to t squared, if we're trying to find the t that satisfies the point 0, 4, then y should be 4. So 4 should be t squared, which means also that t equals plus or minus 2. So plus and minus 2 satisfies both x and y. 0 only satisfies x, so we're going to throw this t equals 0 out. It only works for one of them, and we're going to keep plus or minus 2. And so there's actually 2 different values of t that will give the slope at 0, 4. So let's go ahead and see what's going on here. Let's take t equals negative 2, and let's find the slope there. At t equals negative 2, we know that m is equal to 2 times negative 2 over 5 times negative 2 to the 4th minus 12 times negative 2 squared. And so that's going to be negative 4. And what do we get on the bottom? So negative 2 to the 4th is 16. That's 5 times 16 is 80. Minus 48. This is 80. I believe that's minus 48. It's going to be 32. So we have negative 4 over 32. That reduces to negative 1 over 8. Okay. So our equation then, remember, equation of a line is y equals mx plus b. We now know our slope. Our slope is equal to negative 1/8. And we are given our y-intercept was 0, 4. So that means b, right, this was the y-intercept. That means b is what? What is b? b is 4. So that's a tangent line right there. Y equals negative 1 over 8x plus 4. So that's one of the tangent lines, but we also have to consider the other case, and that's what we get when t equals positive 2. When t equals positive 2, we get m equals 2, instead of times negative 2, it's times positive 2 over 5 times 2 to the 4th minus 12 times 2 squared, which is very similar to the last one. Here we get 4 over basically 32, which is positive 1/8. Which means our tangent line is y equals positive 1 over 8x plus 4. So we get 2 tangent lines at the point 0, 4 for those parametric equations. All right, so let's go ahead and verify this. Let's go to Desmos and let's see if these answers make sense. So we can go ahead and first graph the parametric equations. For x, we have t to the 5th minus 4t cubed. And then for y, we had t squared. And didn't limit t. This is only going from 0 to 1. So we already know that our tangent lines are going to be at t equals negative 2 and positive 2. How about if we just put like negative 5, positive 5 here? Okay. All right, so now let's graph a tangent line. We have y equals 1 over 8 times x plus 4. And then we also had y equals negative 1 over 8x plus 4. So you can see both the green line and the blue line are tangent to the curve at that point, 0, 4. So we verified our solution. The solution looks good. Let's go ahead and go back and look at the next example. Example 2 is again about finding the equation of a tangent line. This one's presented a little bit different though. It says determine whether the following curve will have horizontal and vertical tangents. Well, in order to have horizontal and vertical tangents, we are going to need to know something about what that means, right? So what does it mean if we have a horizontal tangent line? Well, that means if it's horizontal, we got a flat line. X is changing, but y is not changing, right? So we would say that this is true whenever y prime of t is equal to 0, whenever y is not changing. In a similar fashion, we can talk about what we have when we have a vertical tangent, right? And a vertical tangent, then we have a vertical line, x isn't changing, so we would say x prime of t is equal to 0. It's not changing. When you say it's 0, it's not changing. Okay, so let's see what we can do with this. If we have y prime of t is equal to 0, that's going to mean what? Well, y prime is 6t. And if we set that equal to 0, that means t is equal to 0. Well, if t equals 0, what does x equal? X of 0 is equal to 0 cubed minus 3 times 0. 0 cubed minus 3 times 0, that's 0. Then we could find out what y is at 0. Y of 0 is 3 times 0 squared minus 9. That's negative 9. So that tells us where there's a horizontal tangent. There is a horizontal tangent at the point 0, negative 9. X is 0, y is negative 9. All right, so we can, in a similar fashion, we can find where we have a vertical tangent. Go ahead and find that on your own. Okay, let's go ahead and check your work. X prime, if we take the derivative, we get 3t squared minus 3, and that should be equal to 0. And again, we have a polynomial equation, so we can factor. We can factor out a 3, which leaves t squared minus 1 equals 0, which means t squared minus 1 is equal to 0, which means t equals plus or minus 1. All right, so let's check those scenarios. First, that's two values, so let's try negative 1. When we have negative 1, we get x equals negative 1 cubed minus 3 times negative 1. That's going to be negative 1 plus 3 is 2. And then y is going to be 3 times negative 1 squared minus 9. That's negative 6. So 1 point is 2, negative 6. We could also look at t equals positive 1. When we have t equals positive 1, we get x equals 1 cubed plus, or minus 3, excuse me, minus 3 times 1, which is negative 2. And then y is going to be 3 times 1 squared minus 9 is negative 6. So we can say there are vertical tangents at both 2, negative 6 and negative 2, negative 6. And that's a good couple examples there of how we deal with tangent lines and how we find the derivative. We're going to have one more video for this section where we're going to take a look at how to find the arc length of a parametrically defined curve. So we'll see you in the next video. Thank you.